Oh, welcome guys. So this video we are talking about a beta function. Okay. So before I start, be sure to subscribe to my channel and click like button and leave the comment below. Okay, so there are various definitions for the beta function. Yeah. So now so in this video I will connect offline. Okay. So my definition is just this, right? So I just take the gamma b beta functions two variables p and q, and I define to be gamma p, gamma q, gamma p plus q. Okay, and the condition is that the real p and the real q must be zero, much less greater than zero. Okay, so the first one is I want to prove that this similar form I want to show that this bpq is same as 2 from 0 pi over 2 cosine 2 pi minus theta cosine to the power 2p minus 1 and sine to the power 2q minus 1 theta this theta. Okay. And the reason is that let me just remind you guys, this is the definition for the gamma function. I think everyone remember. So we start from gamma p gamma q, then become this. One of these I use. Okay, and then also there's another version is that I already proved by a previous lecture. You're just using t equals to y squared, then you can prove it. Okay, so I use s, and another I use t. Okay, so we can combine it together. So you see there's s squared plus t squared, right? So it tells you that you might use the polar coordinates. So s equals r cosine theta, t equals r sine theta, and r squared equals s squared plus t squared, and this. Okay, so you get 4. You combine this. So these two exponential give you the exponential r squared. So get here this term, and you combine the r, that you get this, and then you combine the theta, you get this. And your region basically is from 0 to infinity, so your region is this space, right? So it's 0 to infinity, and so r is 0 to infinity, theta from 0 to pi over 2, right? So this one. Okay, so the first one, right? The first one, if you see carefully, then this is just exactly 2 times this. Okay, and the rest is this. So this one divided by the gamma p gamma q divided by gamma p plus q is 2 times this integral. So this is another definition for the beta function. Okay, so one corollary is that if you if you put the let me just go to see. Okay, so if we put m p equals to p equals n plus 1, q equals to n plus 1, and the m and n are just integer, positive, maybe positive integer, then this 2p minus 1 is just 2n plus 1. Okay, so this is just beta n plus 1, so it's gamma n plus 1 divided by gamma n plus 2. By definition, this is n factorial n plus 1 factorial. Okay, so this is the one corollary. So corollary gives you the integration of this function. Okay, and I want to introduce 3 usual another definition of the beta function and prove they are all the same. Okay, so remember the first one is what? The first one, what we start is from this, right? So it's cosine 2p minus 1, sine 2p minus 1, right? So this is pi over 2. Okay, and so the first one is I can let t equals to cosine theta. So maybe let me see. Which one is better? Okay, yeah, maybe okay. So let me see. Okay, so if t equals to cosine theta, then dt is minus sine theta d theta. Okay, so if t equals to 0, then when theta equals 0, right, cosine is 1, right? Pi over 2 is 0, and then this is t to the 2p minus 1. and the sine is just, oh, sorry, maybe this is now okay. Yeah, so I set t equals to cosine square. Okay. Then the first term is cosine 2p minus 1. So it's basically, okay, so let me just write down. So dt is just minus 2 cosine sine theta d theta. Okay, so you can check this. This is 2, right? In the 1 and 0, and this is t to the half 2p minus 1, 1 minus t, because sine is just 1 minus cosine square, right? So 2q minus 1, and the d theta is just dt divided by minus 2 cosine theta, so it's this one. And you can see this 1 minus 1 factor cancel. Okay, so finally you can see this gives you another minus 1. So finally you get this. These 2 cancel, you get this 0 to 1, tp minus 1, 1 minus t, q minus 1 dt. Okay, so you start using this. Let me just write out. You use this, then this connected to this. Then we can do this, right? It's just that t equals to x squared. So this, you see, this is correct. And the dt is just 2x dx, so you get another x vectors, so there's a plus 1 here in the 2. And then finally you need to go here, go to this, right? So no, by the way, this is p plus 1. Okay, so the final one looks like that. Maybe I can set this t to be u1 plus u, right? So the first one, I got u1 plus u to the power p, and the 1 minus p is this q, and the dt is just one, right? du, right? So dt is just du divided by 1 plus u squared, and do the integration, right? So you get the denominator and the numerator is u to the p. The denominator is 1 plus u to the p, 1 plus u to the q, and there's a 2. So it's p plus q plus 2 du. Okay. So now we can. So that's it, right? We already connect 3 of them. So that's the common definition for the beta function. And usually I think when I do the calculation, usually I only use this corollary. Okay, so that's it. And the next time we will define this Legendre duplication formula by just using the property of the beta function. And that's it. I will see you guys in the next videos. Be sure to subscribe to my channel. Thanks.